Let's talk about normal distributions, which is another type of continuous distribution. So in this case, the visual is going to look something like the following. It's bell-shaped, symmetric. They call it normal. Now, there's notation here where they're going to have n for normal, and then the mean mu and the standard deviation sigma. So if you think about it, it's like saying shape, center, spread. That's really what it is overall. Now, for example, if they tell you IQ is normal with a mean of 100 and a standard deviation of 15, it's very common. I'll see this all the time online in examples. IQ scores are normally distributed with a mean of 100, standard deviation of 15. Someone with an IQ of 130. Okay, so how far above the mean is 130? That's my first question to you. The mean is 100. The standard deviation is 15. I'm asking for a data value x of 130. Those are all the variables associated with this. 130 is, to no surprise, 30 points above the mean. And you got that by just subtracting the data value x from the overall mean mu. How many standard deviations is that? Well, in this case, the standard deviation is 15, and I'm 30 above. You might say, well, that's just two standard deviations above because it's 15 and 15. And what you actually did is, the formula is you said x minus mu over sigma. To get that, you did, again, 130 minus 100 divided by 15 to get you 2. You're 2 standard deviations above the mean. And the number of standard deviations above the mean is called a z-score. That is a formula you need to be familiar with. So a z-score, by definition, is the number of standard deviations above the mean. This is important. This is like the foundation of stuff you're going to be doing beyond this material. So z-score, z-score is the number of standard deviations from the mean. If your z-score is positive, then you're above the mean. If your z-score is negative, you're below the mean. And if your z-score is 0, then you are the mean. You are the average overall. So it's making sure you know this formula because we're going to apply this eventually to finding probabilities, or given probabilities, finding that original input data value.